Good morning, students. I miss you guys so much, but I'm learning a lot about technology in this time, so you guys are going to be really proud of me. So here is video number 1. We are going to start talking about trigonometry this week. And as you can see here, trigonometry is the relationship between sides and angles of triangles. If you thought we were done with triangles, you are wrong. So this is our last unit on triangles. We're going to do it this week and next week. So this week we're going to start talking about different trigonometry functions. There are 3 of them that we're going to be talking about. But before we get started on that, we're going to talk about a couple of things. So first, this is a relationship between sides and angles. So whenever we're talking about angles, we're going to have different ways to relate them. The most important one that we're going to use is this symbol right here. It's a Greek symbol called theta. And I don't know why they use it, but in math, that's what they use most of the time. So whenever you hear me talking about theta, I'm talking about this guy right here. That just means this angle that's made up of these 2 pieces here, or wherever I want to put it. All right, so now we want to talk about the sides in relation to theta. So we've talked about these before. If we look at what is the side that is across from our angle theta, we don't always say across, we say this is the opposite side. So whenever I can draw an arrow from our angle across to whatever side is across from it, it's our opposite side. So we're going to be talking about our opposite side a lot. We're also going to be talking about the side that is next to our angle. That would be our adjacent side. Adjacent means next to, as we've talked about before. And last but not least, we have our side, the longest side that is across from our right angle. That one is our hypotenuse. All right, so that's going to be our basic triangle and the important sides to know. Whenever you come upon a triangle and we're talking about a certain angle, in this case theta, you're always going to want to label what's your opposite, your adjacent, hypotenuse. That's going to make everything easier. All right, so with that, we should also talk about how this is a right triangle. Every single triangle that we will be talking about in our trig section will be right triangles. You can do trigonometry without right triangles, but we won't hit that in geometry. You'll hit that in algebra 2. So everything we're going to be talking about is right triangles, which hopefully you remember means we have a 90-degree angle in there. All right, so trigonometry, the relationship between sides and angles of triangles. We're going to be using right triangles. We have theta, which just means what angle we're talking about. We have an opposite side, which is the leg that is across from that angle that we're talking about. We have an adjacent, which is the one next to the angle we're talking about, and the hypotenuse, which will always, always, always be the longest side across from our right angle. Now, from there, we're actually going to be talking about trig ratios. So you see I drew this triangle up here again. We still have our opposite, our adjacent, and our hypotenuse labeled. And we're talking about trig ratios. So hopefully you remember this word ratio, maybe when we talked about rational numbers. The word ratio, we just mean fraction. So whenever I ask for a trig ratio, you're going to be trying to draw or write a fraction as your answer. So now we have 3 main functions. We have the sine, the cosine, and the tangent function. Each of these just have to do about different relationships between the sides and the angles. So if I'm looking for a sine, the sine of theta, how we would write that is sine theta. Put it right next to each other so we know we're talking about that. This is equal to the opposite over the hypotenuse. Opposite over hypotenuse. That's just the relationship for a sine function. Now notice when sine is how we actually say it, when we write it, the abbreviation is just SIN, which you'll see on your calculator. We also have the cosine function. This one we would write as COS, the cosine of theta. So you're always taking the sine of an angle, cosine of an angle, tangent of an angle. This relationship, the ratio, is adjacent over hypotenuse. And lastly, we have tangent, which we write as tan. Theta is the opposite over adjacent. So those are our 3 main functions, and they end up being ratios. So the sine of an angle is opposite over hypotenuse. We're looking at the relationship between those sides and the angle that we're given. So if you look at this, you might want to write these down. Actually, definitely write these down. Sine theta is opposite over hypotenuse. Cosine theta is adjacent over hypotenuse. Tangent theta is opposite over adjacent. Now, when I learned this back in high school, and many of your parents probably learned it this way as well, there was an acronym. It's SOHCAHTOA. And personally, I write this every single time. I say it all the time. SOHCAHTOA, SOHCAHTOA, SOHCAHTOA. Try saying it. SOHCAHTOA. What this means is it's just showing you the relationships. It's saying sine is our opposite and hypotenuse. Cosine is our adjacent hypotenuse. Tangent is our opposite and adjacent. And that's how they go together. Those are the ones that relate together. So this will just help us later on when we're given very limited information. If we know we're given an opposite and a hypotenuse, we know we're going to have to use the sine function, and so forth. All right, so keep these in mind. I would definitely write these down. Yes, do that right now. Cool. All right, now that you've written those down, we're going to use that information to actually find some trig ratios. So we just talking about SOHCAHTOA. I'm literally going to write that right here so I remember and can reference this as we're going forward. So now this example is asking us to find the following trig ratios. So if we're looking, I have two different angles we're looking at here. We have alpha, this one is theta, and then this one is alpha. They also could say sine of A or sine of B or something like that, referencing the angles. So now if we're looking for the sine of theta, I know my angle theta is here. I want to look and I'm going to label my picture using just the alpha. So first things first, this is our hypotenuse always for theta. Well, for any of the angles, because this is always the hypotenuse. Now, theta, also, we want to look across from it, is 4. This is our opposite. And 3 is the leg that is right next to theta, so this is my adjacent. So I labeled my picture right off the bat with our opposite, adjacent, and hypotenuse. Now, if I'm looking for the sine of theta, I look here, I have sine. Sine uses opposite and hypotenuse. So I look at where I labeled, and I have a 4, opposite over hypotenuse 5. That's my trig ratio for sine. Then, if we're looking for cosine of theta, cosine is my adjacent and my hypotenuse. So I look at theta, my adjacent is 3, hypotenuse is 5. I have 3 over 5. Tangent of theta, I'm going to use my opposite over adjacent. So I look at my theta, my opposite's 4, adjacent's 3, I end up with 4 over 3. Easy enough, you end up with just a couple of fractions there at the end. Now, if I'm looking at alpha, which is the other angle, I'm going to redo what I'm talking about with my opposite, adjacent, hypotenuse. Hypotenuse luckily stays the same, but now my opposite is 3 and my adjacent is 4. Keep in mind with alpha, I'm always using this purple color, so we don't need to look at these orange colors anymore. That only had to do with theta. So now, if I look at sine of alpha, sine is opposite over hypotenuse, so I look at my opposite of 3, hypotenuse of 5. Then we have cosine of alpha. Cosine is adjacent over hypotenuse. So I look and I have 4 over 5. And then if we're looking for tangent of our alpha, tangent is opposite over adjacent. So I look at my purple ones and I have opposite is 3 and adjacent is 4. So I end up with 3 over 4. And maybe you'll notice something here. If you look at our sine and cosine of our opposite angles, and then cosine of the first one and sine of the second one, these are opposites of each other. So sine and cosine, they're inverses, or they're opposites of each other. So that's just something to keep in mind as you're going forward. When you're looking at the same triangle with two different angles on it, the sine and the cosine will be the exact same for the opposite angles. Awesome, so tune in to my next video and that will talk to you about why these ratios are important and how they actually can help us get the angle measurements of each of the triangles.